section 8.1, estimating mu or mean when standard deviation is known. Chapter 8 is all about estimation. So we're going to make estimations and inferences about data, and in this particular chapter is all about the mean. So what are we going to assume or initially start with? We have to have a simple random sample. So you're going to be given a sample, and then a variety of things is going to happen. In this section in 8.1, we will know the population mean. It is known. Okay? And we're going to basically assume that the distribution is normal so that we can use any sample size n as long as we know that the population standard deviation, then we know it's going to be normal. Okay? So if the population or if x is unknown, we have to require a sample size of 30. So we kind of talked about that. Either it has to be normal and be under 30, or if it is not normal, or if we don't know the distribution, the n has to be greater than 30, and then we can proceed as long as we know the standard deviation. Okay? So if you ever hear me say a thing called a point estimate, okay, all that is, if you think about it, is an estimate of the population parameter by a single number. In this case, it's going to be the mean. Okay, x bar in a sample is going to be our point estimate. So if we take a sample of 35 things and we compute the mean, that's going to be our point estimate. And then what we're going to do is we're going to estimate the mean of the entire population, doing what we do the rest of this section. Okay, in order to do that, there's going to be margin of error. There's going to be things that can come up that we cannot necessarily realize can happen. No different than in the election on Tuesday or on November 6th, whatever way you want to think about it. There will be margin of error, and every time you see a state be called to a president or Governor Romney, it's going to be plus or minus some percentage. That's your margin of error. Okay? What is margin of error? It's just a difference between our actual value to the actual mean, and that's going to be a margin of error that we're going to see throughout this entire section. To get and the broad estimation of a mean, we say is a confidence interval. So confidence levels, confidence intervals is what we're going to make. We need to have a confidence level. How exact do we want to be? Confidence level is going to be anything from 0 to 1 that corresponds to an area underneath a curve between z and negative z, which you guys have done this before. Z to negative z, and maybe inside we want 0.95 or 0.98 or 99%. There's a variety of different levels that you can be. And what we're going to do is we're going to build this confidence level, and then essentially the area underneath the curve is going to be that level. Okay? So, for instance, if I want a 99% confidence level, I want to be 99% positive of estimating this mean, which means my critical value, this is how I write this, the z critical value is z sub 0.99 over z sub negative 0.99, which, by the way, I need a negative in one of those. I didn't do that. Okay? That means that 99% of my data need to fall within negative z and z. I need to find that z-score. Okay? I need to know what the z-score is that gives me this value. You guys have done this before in Chapter 6. So what you need to do is find, this is 0.005 here, and 0.005 there, because there's only 1% left over. Okay? So if you're going to do that, you need to go to your z-score table and find the value in here that's closest to 0.005. Now, I'm still dumbfounded by our book and why they actually put it as 2.58. I'm not sure, to be completely honest with you, because I taught you guys that it should be right in between and probably should be 2.575, but since they want to use 2.58, we're going to use 2.58. And it's going to be okay because there's a table on your z-score table, which I don't have that on me. I'll show you in class on that. But the critical values are actually listed. So with a 99% value, it's 2.58. Okay? Here is a list of scores. Now I'm going to either give this to you, or basically these are the common ones that you should be able to figure out. Now notice that the 2.58 is here. If you would say 90, let's say the 95%. Okay, it's the only other one I'm going to do. I want 95% in the middle. So if you are like, well, I have no idea what's going on right now, see if you can do this. 95% in the middle means what's left over in the tails. That's 5% total. and they're split to both sides. So can you go in and find 0 or 0.025 in your z-chart? What z-score does that relate to? You should find 1.96 as your z-score. Actually, negative 1.96 here, and then positive 1.96 will be over there. And that's how you're going to use your z-critical score. Okay? So that's the how far away from the mean I need to go, all right, in order to make my confidence level. And that's what we're going to kind of build towards. Okay? Recalling from sampling distributions. If you take sample size n from our population, then the distribution of the sample mean has the following characteristics. Remember, the more you get, the mean's just going to be the mean. If you take enough samples, you're going to actually come up with the mean. The standard deviation, on the other hand, is going to be the original standard deviation divided by the square root of n, because as the samples increase, they're going to shrink. Okay, so that's kind of the idea, though that's not going to change at all. And what I want you to do now is find your Chapter 8 formulas, which is going to actually be on the second or the back side, the first page, and we're going to look at the first two columns. Okay, if you notice, there is an E equals Z sub C times standard deviation over the square root of n. This right here, okay, and on that page is E equals. This is our error. We want to estimate the mean, but we do not know how far right or how far left we're going to go. Okay? Square root, or standard deviation over the square root of n is your standard deviation of this sampling distribution, correct? And the z-score simply is telling you how many standard deviations away we need to go. And that's going to be your error. That's how far. Say if I want to go 2 standard deviations left or 2 standard deviations right times that standard deviation, that gives me my error. So that's what we're kind of going for. Alright, so the top formula that I believe you have says E, or the x bar minus the E, and so on and so forth. This is where it's coming from. Okay, so your difference, alright, from the sample x bar you get from your mean should only be your error. The standard deviation, whatever that is, times your however many standard deviations we want to go. Okay, so the probability the sample mean will differ from the population mean at most, that's how much it's different, is our little error formula. So the maximum amount of error, here's our E, that's what I was telling you before. If you can find the error, you just add and subtract it from your x bar, your mean that you found. Okay, so this is the should be the top formula on your note sheet. So this is the one I want you to kind of gauge at. This is what we'll start with. And I want you to kind of see if you can follow along with what I'm going to do. So salaries of a community college math instructors are historically known to be normally distributed. There's a big thing. It's normally distributed. Okay? Standard deviation of 3,500. Now, when it says historically known, that is your population standard deviation. Standard deviation is 3,500. Oh, that pen is not working very well. You make a random sample of 33 instructors, so that's your N, is 33. And the mean salary is 53, so your mu, I lied, X bar, because that's a sample, is 53,128. And it says determine a 95% confidence level for the mean salary of these math instructors. So what you need to do is essentially estimate mu, and the 3 things you need to know are the, now in this section you want the population standard deviation, you need an N, and you need an initial sample, a starting gauge of your mean or your X bar. Okay, so I'm going to try to go through this a little bit slowly. I'm sure you're going to have to push pause because I've actually already done most of the work for you. But this is what I wrote on the previous page. N is 33. X bar, the initial setup of the mean, is 53,128. Your standard deviation is 3,500. I want a 95% confidence level. So if you either figure it out on your own with the, and I already did this one, But if I want what is your z-score, where 0.95 is in the middle, okay, you need to go find 0.025 in your z-table, and what z-score does that relate to? Or go to that little table, and 95% relates to 1.96. So the z-critical value is 1.96. And what you're going to do is calculate the error. If you look at this formula right here, all I need is the z-critical value. Check, 1.96. Standard deviation, check, 3,500. Square root of n, so the square root of 33. You have all the pieces of information to find your error. Okay? So then it's 1.96 times 3,500 divided by square root of 33, and you should get 1194.17. So you guys can calculate that right now if you wanted to. And that's the number we are going to dump in and add and subtract to our x-bar. X-bar is the initial mean. You're going to have to find a sample and have a starting spot. So in this section, or in this example I should say, is 53,128. That was the initial sample mean of the professors that they found in this sample or group, the people they called, and you just dump those numbers in. And you build an interval. Your answer is going to be an interval. It's the 53,000 minus the 1,100 and 53,000 plus the 1,100. And that's going to build an interval. We can estimate that the average salary for a math instructor at the college level is between $51,900 and $54,300 based on our information. Now, we just don't want to leave it that broad, because people will pick that apart. If you put this in the media and the newspaper, people will pick it apart. So in this chapter, you must write out your answer in a, I don't want to say paragraph because that might freak you out a little bit, but in sentence form. And here's an example of what I want you to write. You must say 3 different things. You must tell me the confidence level. So I say we conclude with a 95% confidence. That allows for mistakes. That allows for, you know what, it can happen that, you know, there's professors that are outside or inside of that. Okay? So you need to tell me the confidence level. Need to tell me your answer, which is your interval. So I said, okay, conclude with 95% confidence level that the interval from 51.9 to 54.3 contains what? What does it mean? Tell me essentially what you're finding in the problem. The mean salary for all community college math instructors. And all of your answers in Chapter 8 must have a paragraph like that. Okay? So that's where we're going. And the rest of this year, basically, you're going to be writing out things because we are estimating. Alright? Multiple confidence levels. I'm going to do this quickly. Basically, if you repeat this confidence level thing over and over and over again, the amount of confidence levels that include the real mean is going to be proportional to your confidence level, if that makes sense. So if you had a 90% confidence level, just because this is the easiest number I could think of, 9 of 10, if you would do this 10 times, 9 of the 10 should include the real, absolute, true population mean. One of them might be either too high or too low to the mean, but it should be proportional to that. So that's kind of what we mean by confidence levels. 90% of the time when we do this, it will include the mean. Or 95% of the time that we do this, then it should be 95 of 100 times, you would include the mean. So that is that section. It is just about finding the error. If you can find the error, that error formula, and then dump it into your interval, it's not too bad at all. So we'll do this assignment in class, and you guys have a great day.